guys, this is chapter 12, section 4. Angle measure and segment length. Alright, so there's a few theorems here in this one. They're all sort of algebraic mathematical ones. And theorem 1213 says that we have a circle. And with this circle, we have two lines that go through the circle, like so. And with these two lines, we have intercepted arcs here. And call that one X. You have another intercepted arc on the other side. We call this one Y. And then we have an angle. We can call that angle number 1. Alright, we want to try to find angle number 1. And in order to find angle number 1, we say that that's half the sum of arc X, intercepted arc X, and intercepted arc Y. Okay, so if we wanted to find this guy, we add the two arcs that they intersect on both sides and divide it by 2. That is 1213. The measure of the angle formed by the intersection that of two lines that intersect inside a circle is half the sum of the measure of the intercepted arcs. And then we have 1214. And in 1214, instead of having two lines that intersect inside, we have and then form the angle inside, we have a circle in which we have an angle out here. And we want to find this angle. We call that angle 1. And then we have an X over here and a Y over here. And to find out what angle 1 is, it's instead of adding the X and the Y, we are subtracting X minus Y. In this scenario, X of the intercepted arcs is always going to be bigger than the Y. It's always going to be bigger than the Y. Because as you come closer to one angle, the rays get closer and closer. So this part is going to be wider with my angle than this part, always, as we come back to some common point that the ray cuts into. So X will always be bigger than Y. You'll always have a positive number in this scenario. There's 3 cases. Alright, case number 1, the ray side of the ray goes through 2 intersection points into the circle. So these guys intercept the circle at 2 points. So that's case number 1. Case number 2, and it has the same exact equation. The equation doesn't change. We have a tangent line and one line that goes through. So you still have an x over here, and you still have a y over here, so the equation still holds true. All right, nothing has changed in that regard. It's still 1/2 x minus y to find some angle 1. All right, so that's case number 2. You have one tangent line and one line that goes through through the circle at 2 points. And in case number 3, you have two tangent lines. All right, we have two tangent lines. We have an x over here, and we have a y over here. All right. Still x minus y, 1/2 of x minus y. But now both of the lines are tangent. So those are the 3 scenarios. Two sides of the angle goes through the circle. One is tangent and one goes through, case number 2, or both of them are tangent, case number 3. In either of the 3 cases, we still get the same equation. Measure of that angle is equal to 1/2 of the difference of the intercepted arc. And we were talking about a line that goes through a circle. So if we have a line that goes through a circle, let's say this is circle O, and they intersect at 2 points like this, right, we would say that this line is secant. So line AB is secant. And what secant is a line that intercepts a circle at 2 points. A line that intercepts a circle at 2 points, we would call that a secant line. Okay. Okay, so to do a few of these, math-wise isn't that bad. So we have this guy right here. I'll try to draw it as best I can. We have a tangent this way and a tangent that way. We're told that that's 70 degrees. And we're told that this guy over here is 110 degrees. So what is this guy? Well, we could actually do it 2 different ways. But I'll do it with that equation. So this is the angle, measure of the angle here. So 70. And it equals 1/2. The measure of, we'll call it, they call it W. W minus 110. Multiply both sides by 2, 140 equals yeah, 140 equals W minus 110. Add 110 to both sides. W equals 250. So that's one way to do this particular problem. There's another way to do it. Since these are tangent lines, since these are tangent lines, and they meet right here, uh, we know that a complete rotation of a circle is 360 degrees. So what I can do is I can subtract 360 minus 110, and that actually equals 250 as well. So that's one way to get that number as well. Only works when you have case number 3 when they're both tangent lines. It doesn't work when they're secant lines, or one tangent or one secant. Then you get a different scenario. Okay, so for B, we have that this guy here is 30. We have that this guy here is 110. They want to know what this guy is. Alright, so y is going to equal 1/2 of 110 minus 30. So y equals 1/2 of 80, and then y equals 40. Okay, y equals 40 degrees. And then C, we have that this guy here is 30. This guy is 35. They want to know this guy is. Alright, so here we would have 35 is equal to 1/2 x plus 30. So multiply both sides by 2. 70 equals x plus 30. Subtract both sides by 30. X equals 40. All right, so this one with the satellite problem. So they don't give us any of the arcs, but they give us that we have 2 tangent lines, and they give us the angle. And in this case, they give me that the angle is 20 degrees. And we have this angle here. Again, they don't give it to us. So we're going to call this x, because we don't know what it is. Then we have the other side. And again, we don't know what that is either. But since I know that a complete circle or a complete rotation is 360, and I know that, let's call this y for right now. I know that y, or x plus y, equals 360. To find out what y is, I would just subtract x from both sides, right? Minus x. Minus x. That goes away, and I get that y is equal to 360 minus x. So instead of writing it as y, I'm going to say, okay, I know that y equals 360 minus x. I'll write 360 minus x instead of y. And the reason why is the reason why I'm doing that is because I want it in terms of one variable, so I can solve for one variable and then plug it in and then get the other one. So since it's a tangent line, I can do, and the angle is on outside of the circle. I can do the equation of 20 degrees equals 1/2 of 360 minus x minus x. That turns into 360 minus 2x. Alright, so I can do this in two ways. I can use the distributive property and distribute 2 through this. And this would be 180 minus x. Or I can multiply both sides by 2 and get 40 equals 360 minus 2x. Either way gets me to the same answer. The book distributes, so I'll be consistent with the book. Half of 360 is 180. And then half of 2x is x. Subtract 180 from both sides, and I get negative 160 equals negative x. Multiply both sides by 2, or by negative 1, and I get that x equals 160. So this guy, x, is 160. This is going to be 360 minus that. So then this guy is 200. They want the measurement of the angle closest to the satellite, so x is 160. And we have theorem 1215, and this also has 3 cases, but the equations are not the same. They're 3 different equations. So what this one says is that if I have a circle, and this is case number 1, if I have a circle and I have 2 lines that go through it like this, they meet at a common point. Right. Let's say that this is A. Let's say that this is B. Let's say that this is C. Let's say that this is D. I can say that if I multiply A and B, this is the theorem. A times B, that is equal to C times D. So they intercept right here. If I was to multiply A times B, that is going to be equal to the product of C and D, or C times D. These guys are equivalent. Alright, that's case number 1. Case number 1 is a situation where both of the lines are chords that goes through the circle, and I can multiply their intersection point. And case number 2. Case number 2 is when they're both angles, and there's a common point outside of the angle, and it goes through the circle. So case number 2, I have some common point out here. Like so. This is now my intersection point. I have 2 intersection points. And I have this case right here, and it goes through right here. And now here I have 2 intersection points. We call this guy Z. We call this guy Y. We call this guy X. We call this guy W. All right, from these 2 intersection points. W is on the outside of the circle. X is on the inside of the circle. If I was to add X and Y, X and W, and then multiply it times the outside length, so the length from, they call it P, from P to W, or W, I multiply that times the whole entire ray itself, or the whole entire line itself, segment, X plus W. That is going to be equal to Y plus Z times the outside segment outside of that line, or outside of the circle of that line, times Y. Okay? So we have the same line here, and if you think about it, right, it's the same case right here. The outside Y times the line, the outside W times the line. Okay? That's case number 2. Then we have case number 3. Case number 3, we have a one line that's tangent and then one line that goes through the circle, or secant. So one line that's tangent and one line that's, I should make that blue. One line that's tangent and one line that is secant, goes through 2 points. Yeah. Intersection point here, and then the other intersection point here. We're going to call this T for tangent, and then we're still going to call this one Z and Y. Alright, so for this one, since there is no inside of the circle to multiply by, we multiply it by itself. So T times T, or T squared, T squared that's going to equal Y plus Z times the outside Y. Alright, so those are the 3 scenarios. And they all have their own separate equations. Alright. That's case number 3. Alright, this is case 3. And then we had case number 2. And that was X plus W times W. And that equals Y plus Z times Y. And then we had case number 1. And that's the one that's everybody likes. A times B equals C times D. Alright, so those are our scenarios. Alright. Alright. So here, we have a circle. Go here, go here. Up here is 20. Here's my intersection point. Here's 14. Here it's X. Here's my intersection point, and that's 16. And so we have this is case number 2. So this is going to be 20 plus 14 times 14 is equal to x plus 16 times 16. Alright, so there's a few ways to do it. We can add the 20 to 14, so that's going to be 34 here, and 34 times 14 is 476 equals x plus 16 times 16. Here I'm going to divide both sides by 16. Get rid of that guy. I get 29.75 equals x plus 16. Subtract 16 from both sides. And I get x is equal to 13.75. So that's using case number 2. Here, this is case number 1. Here I got that, so this is going to be 6.5 and m. This is going to be 3 and 7. So for this one, it's going to be 6.5 times m. That's going to equal 3 times 7. So that's going to be 6.5 m equals 21. Divide both sides by 6.5. And I get that m is equal to 3.23. Okay. Alright, you guys, that is this section. Hope you have a great rest of your day.